Today's lesson is on the area of polygons. It's kind of going to be a review lesson over a lot of stuff you've done in the past, maybe a little new stuff, but mostly just kind of reminders so we can move forward into our unit on volume. Our EQ today is how do you find the circumference, perimeter, and area of different shapes. So our definitions we should think about today are polygon, which is a multi-sided shape, starting with triangles and all the way up and through decagons, which have 10 sides, quadrilaterals with 4 sides, pentagons with 5 sides. Perimeter, the sum of all the sides, which will always be written as a capital P. So if you want to find a perimeter, you just add up all the sides of a shape. The area is the total space inside a shape, and it will always be symbolized by a capital A. And of course, we also have this thing called an apothem. This is a new term for you guys. It's the length from the center of a polygon to the middle of a side. And we'll talk about that more once we get into the area of regular polygons. If you need more time copying this screen, pause it. All right, our first shape we're going to talk about is rectangles and squares. These are shapes you've worked with before. The way we find the perimeter is we take the width and the length and we add up 2 lengths and 2 widths. To find the area, we multiply the length times the width. This is the same thing we do for both rectangles and squares. Let's try a quick example. What is the perimeter and the area of the shape below? The shape below is a square. To find the perimeter, we're going to add up all the sides. The sides are 5, 5, 5, and 5. So that's 5 plus 5 plus 5 plus 5. So our perimeter is a total of 20 inches. Now let's find the area. The area is going to be length and width. This is my length, this is my width, so we're going to do 5 times 5. My total area is 25 inches squared. Make sure you are always putting inches and inches squared for perimeter and for area. We can also work backwards. We can use an area of this rectangle. The area of this rectangle is 60 inches squared, and we can use it to find the length if we have one of the sides. The area of a rectangle is found by doing length times width, and the area of this rectangle is 60, and we have a width, but we want to find the length. So let's plug in a 5 into the W. And to figure this out, let's divide both sides by 5. And we end up with a length that would be equal to 12 inches. Parallelograms have a very similar way of finding perimeter and area. The perimeter of a parallelogram is all 4 sides added together. 2 of the sides we can call S for side, and then parallelograms have a base, and that B would be the same on top and bottom. So we add up 2 S's plus 2 B's, and that's how we get the perimeter. Area is similar to rectangles in the way that we just multiply 2 numbers, but parallelograms typically call it by base and height. It's important to realize that heights are always perpendicular to a base, always. Okay, so height is always perpendicular to a base. It's important to remember. And once you know those 2 numbers, you just multiply them. So let's find the perimeter and the area of this parallelogram. We need to make sure we use the right numbers. So our perimeter is going to be found by adding up all the sides. We have a 5 and a 5, so that's 5 plus 5, and a 9 and a 9 for top and bottom, 9 plus 9, giving me a total of 28 centimeters. My area, which we need to make sure we pick out the right numbers, 9 is a base, and 4 is my height. So I'm going to multiply 9 times 4 and come out with 36 centimeters squared. Again, remember the difference between centimeters and centimeters squared for perimeter and for area, and make sure you know which is the actual height of the parallelogram and don't accidentally use one of the sides. The area of a parallelogram is 56 feet squared. We find areas of parallelograms by multiplying the base times the height. What is the height of the parallelogram if the base is 7? So we're going to plug in 56 into the area, and we're going to plug in a 7 into the base and figure out the h. Since it says times, let's divide both sides by 7, and I figure out that my h is what 56 divided by 7 is. It's 8. 8 feet. Our next shape is the trapezoid. Trapezoids have two different bases of different length. So to find the perimeter of a trapezoid, you're going to have to add up the two bases plus the two other legs. To find the area, we use this formula. The height of the trapezoid times base 1 plus base 2, all divided by 2. Just like with parallelograms, make sure that you are picking the right measurement for the height, because heights are always perpendicular to a base. What is the area of this trapezoid? Well, I see I have my height, and I don't really see what my base is because I have these multiple numbers. I think all these together would be my base number 2. 6 plus 2 is 8, plus 2 is 10. And if I think about the fact that this would be a rectangle, I think I need to slide the 6 up here, and I have my base number 1. Now let's plug this into our formula. The height is 4 times base 1 is 6 plus base 2 is 10, all divided by 2. So my area is going to be equal to 4 times 16 divided by 2. So my area is equal to 32 units squared, since they didn't give me inches or centimeters or feet. In our second example, it looks like we don't really have a height, but sometimes one side of the trapezoid could be a height as long as that side is actually perpendicular to a base. So in this problem, which at first glance doesn't look like it has the right things because it doesn't have that dotted line in the middle of the trapezoid, in reality, the 5 really is the height. So let's plug these things into our area formula for trapezoids. Height is 5 times base 1 is 8 plus base 2, which is 12, all divided by 2. I'm going to have to do 5 times 20 divided by 2, which will be equal to 50 inches squared. Our next shape is circles. Circles are a shape that you have used often in the past. Let's remind ourselves of the important pieces of circles. The first piece is the diameter. The diameter is a line that goes directly from edge to edge of the circle, but it also goes through the center. It's always represented by a lowercase d. If you draw a line from the center of the circle to the edge of the circle, this is called the radius. It's always represented by a small r. To find the circumference of a circle, we use pi times d, or some of us are more familiar with pi times 2r. You can use either of these formulas. Use the one you are most aware of and have used in the past. To find the area of a circle, we do pi times r squared. Now remember that pi is a decimal number that goes forever, but you can approximate it to 3.14. But we're going to be using a pi button in our calculators to calculate our area and our circumference. So make sure that you know how to type pi when you use one of the calculators. So let's find the circumference and the area of this circle. The circumference of the circle is found by doing pi times diameter. We have a diameter, it is 8. So we are going to multiply pi times 8. Remember, we're going to type the pi button into our calculator. We're not going to type in 3.14. So pi times 8 comes out to approximately, not actually equal, but approximately 25.13 meters. Now let's find the area. The area is done by doing pi r squared. Now, I don't have an r, but I can figure out my r by dividing the diameter in 2, because the radius is always half of the diameter. So my radius is actually 4. Let's plug this into our area formula. Pi times 4 squared. Remember to square the 4 first before multiplying. 4 squared is 16. And now I'm going to do pi times 16. I end up with 50.27, and this is rounded, meters squared. Let's take a look at a more realistic, possible real-life application of these things. A city wants to build a crosswalk across a circular intersection. It takes 100 feet for the cars to drive around it. How long will the path be across the center of this intersection? So the cars are traveling around this circular intersection, and it's 100 feet going all the way around this intersection. Then this is the same thing as circumference. So my circumference is equal to 100. If I want to figure out how long it is across the intersection, then what I'm asking for is diameter. So what is the diameter? Well, let's remind ourselves of what the circumference formula is. It's pi times diameter. So I could plug the 100 into the C and work this formula backwards. 100 equals pi times d. So remember, pi is not a variable. It is actually a number, so we can divide by it. So let's divide both sides by pi. And now my diameter is going to be equal to whatever 100 divided by pi is. 100 divided by pi is 314.16 approximate feet. The last thing we're going to talk about is visualizing shapes as a part of 3D shapes, and these things are called cross-sections. So if we were to take a cylinder and we were to slice it through the middle of it so that the slice is parallel with one of the bases, what we would end up with is the shape of a circle. If we were to slice that cylinder diagonally to the base, we would end up with the shape of an oval. And if we were to slice through the cylinder perpendicular to the base, so up and down, we would end up with the shape of a square. So what is the cross-section of a cone when cut parallel to the base? Well, if we cut through like this, we would end up with a cut that kind of looks like this. And so the cut would actually be a circle. But what would you get if you were to slice it perpendicular to the base? Yeah, what would be the cut that looks more like this? Well, it would be actually a triangle. Okay, that wraps up our video on area of polygons, which is a lot of review. Don't forget to hit the submit button because I need to have record that you actually watched the video. If you have questions, just write them down, call me over, and let's talk about it.